Assignment 38-39, permutations and combinations. So let's see if we can see the difference. So on this one from 9 through 12, it says tell how many permutations and combinations. The permutations are when the order matters. Right. So let's go ahead and look at maybe the number 11. Use your paper from yesterday. Do you have a line sheet of paper? And number, if you don't, I've got, in fact, here. Go ahead and put this on that table if anybody needs any. Put that stack right there. So on the number 11, we're going to do it, we're going to try to do it mathematically, and we're going to try to do it where you make a chart. So it says, if I have the letters A, B, C, D, E, the permutation is where the order matters. And I'll say we're going to pick two people. Let's see who's going to be president and who's going to be vice president. Okay. Because the order matters. So let's find all the different ways that we can do it. So A can be president. Tell me somebody, and let's go in order. Who do you think the vice president could be then? B. Let's go in order. Otherwise you get all mixed up. Or A could be president. Who else could be vice president? The C. Or A could be president. And who could be vice president? D. Or A could be president and what? And E could be vice president. Then, and so that's already, yeah, that's 4. And then I'm going to have you guess in a few minutes how many different ways we can do this. So this is the permutation where the order definitely matters. So on the next one it is B could be president. In fact, I'm going to put B all the way down. And if B is president, who could be his first vice president? A. Go back to A. Because this time, these are totally different on a permutation because the order of president and vice president matters. I can have these two where they have the same letters. Because this time A is president, next time B is president. And then so it's going to be A, can't be B. Next one's going to be C, D, and what? E. Then, who's the next guy that could be president? C. And so I'm going to put C all the way down. And then C could be president. A could be vice president. C could be president. And then who? B. Could I have CC? No. The next one would be what? The D and the E. So, by the way, 4 here. 4 here. Who has an idea how many we're going to end up making altogether? Are you getting this down, Mateo?
12.
It's going to be 20 because I've got 4 in one group, 4 in the next group, 4 in the next group, and 4 times 1, 2, 3, 4, 5 is going to be 20. But let's go ahead and keep on going because we're going to use this for something. Then the next guy that could be president is D. And then his first vice president could be A. The next vice president could be who? B. The next one could be what? C. Could it be D on the last one? Could it be DD?
No, D.
Then it would be E. Okay. So we're almost done. On the next one, E could be president. So E. And then his first vice president could be A, could be B, could be C, could be D. And those are all the possibilities that we have for vice president and president. So you can see the total number is 20. Right. Let me see if there's another one that's a small one. That's 20. Oh yeah, here's another small one. 2 different ways. Okay, let me go do this. Then, the shortcut way for a permutation is one of the easiest if the ordered matter. So, how many people am I going to have as president and vice president?
5.
What? 2. In fact, in the book, it's saying, let me open this up. Oh, we're looking at this one right here. We're looking at 2 of these 5 letters. 2 people are going to be president or vice president, where the first time the order matters. So here's how you do this. I'm going to put a 2 here, 2 little lines. How many possibilities did we have all together? How many people could have been president? 5. 5. So A, B, C, D, E. Let's suppose A becomes president. How many people are left to become vice president? 4. It could be B, C, D, E. So 5, but you still need to know how to do it this way. 5 times 4 is what? Is 20. There's a different, we're doing this twice because there's something else that they want you to find. So I'm going to go halfway down the paper and we're going to start the number 12. The 12, it's 2 again, but this time there's only 4 people. Okay, so 2 people. And again, the order matters. It could be who's going to be pitcher and who's going to be outfielder. In fact, that's what I'm going to use. So on number 12, I'm going to say pitcher and outfielder. And we've got jersey number 3, jersey 7. I'm sorry, I skipped the 5. Whoops. 5, 7, and jersey 9. 3, 5, 7, 9. Okay. So we're going to do this one. Permutation. We're going to do the permutation where the order matters. So who could be pitcher first?
3.
The jersey 3. So 3, and then who could be outfielder then? In fact, this one, because they're numbers, I have to draw a line. 3 and 5, or 3 and who? 7, or 3 and who? 3 and 9. So that's the first group. Then the next one, then who could possibly be a pitcher the next time?
5.
Actually, I can put a comma. 5, and could 3 be the outfielder then? Yes. And then 5 and who? 7. And 5 and who? 9. Okay. All right, so we've got that. Then 7 could be the pitcher. So 7, 7, 7, comma. So his outfielder can be who?
3.
The 3, and then who? The 5, and then who? The 9, because it can't be 7, it has to be 9. Okay. And then we've got one more. The 9 could be the pitcher. So the 9, 9, 9. Because there's 4 people, if 9 is the pitcher, then there's only 3 left. So 9 could be the pitcher and 3 could be the outfielder. 9 could be the pitcher or who?
5.
5 could be the outfielder. 9 could be the pitcher and who?
7.
7. So I think we've taken care of it. So let's see how many that is. That's 1, 2, 3, and there's 3 here, 3 here, 3 here. All together, that's how many?
12.
All together, that's 12. Okay. And I'm doing this slow because the next part is a little complicated. So these are permutations where the order matters. Here is the shortcut way. So the shortcut way is I'm choosing 2 people. And I have a possibility of the 3, 5, 7, or jersey 9 being the pitcher. How many choices is that?
4.
4. And if 3 is the pitcher, how many are left to be outfielder? 3. 5, 7, and 9. 3. And so 4 times 3 is what? And so we get 12. Okay. So those are the answers for the permutations. So for the permutation, where the order matters, the first one was 20. And the second one, where the order mattered, the permutation was 12. But now they're complicating it a little bit. And this is where it gets a little crazy. Okay. It was already crazy, but now it reverts back to one we did yesterday. But now, this time the combinations, the order, it doesn't matter. I'm just going to put this. The order doesn't matter on combinations. So if it doesn't matter, 2 people are walking to school. Is A walking in B the same thing as B walking with A? So this is where I'm going to cross anything out that's already there. So AB, can I have a BA? On combinations, the order doesn't matter. So it's like 2 people walking to school. Okay. AC, can I have a CA? So we're going to start crossing these out. And I should use pencil, but it's okay. I'll use my pencil in case I make a mistake. Okay. So, yeah, Ann and Kathy, Kathy and Ann, same people. I have to cross it out. Then, AD, can I have DA? No. Not with a combination. Combination is don't count. Should I say double? Don't count the same combos. Okay. So here's AE. Is Alice and Edward the same thing as Edward and Alice? So with a combination, I have to cross that out. So now let's look at we've checked all those. BC is Barney and Clark, the same thing as Clark and Barney. So we have to cross this one out. And then let's look at the BD. So the BD, that's this one here. Okay. That's the same thing as DB. So same people, we're going to cross them out. BE, Betty and Edward. It's the same thing as Edward and Betty walking. We don't care how they walk. The order doesn't matter how they walk. So I'm going to cross them out. Then I'm done with that column. So let me go to this one. CD. In fact, it's right here. Is Candy and Doug the same thing as Doug and Candy? So I'm going to cross this second one out. Always cross the later one out. Then I'm right here. C and E. Candy and Edward. Is that the same thing as Edward and Candy?
Yeah.
So I'm going to cross that one out, and you should be doing the same. Then, so I finished that. And then Doug and Edward. Is that the same thing as Edward and Doug?
Yeah.
Yes, cross that out. So now the combinations is equal to, let's see how many we did not cross out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The combination is 10. All right. Yes?
The combination, can't you just undo it?
Good thinking. It doesn't happen always, but here's how it works. Is you do to get this, you take your permutation, which is 5 times 4. And then, how many people were we having walk together? 2. So I need 2 lines. And this time I put how many, I'm going to have walk together. I put 2 times the one number lower. By the way, these are called, what is that called? No, they're called factorials. The factorial, 5 factorial over, and you don't need to know this really, but I'm just writing it, 2 factorial. What that means is when you see that, that means you're going to write, no, I can't do it on this one. Never mind. Ignore me. It is, but it isn't. It's sort of. But anyway, I'm going to decrease the number. So 5 times 4 is 20. 2 times 1 is what? 2. And this is, how do I say this? This is the number of ways that I'm doing something. So this is how I get my combination. Take my permutation divided by the number of ways descending on the multiplication. So 20 divided by 2 gives me that 10. So 2 distinct things. So again, where the order mattered here, okay, the order matters here. Now, I'll use maybe the same example. I'm going to think of them as people. They're walking to school. 2 people are walking to school. And again, the choice was 2. First of all, I'm going to put my permutation, which is 4 times 3. How many people were walking together? 2. So I'm going to put 2 lines, 2 times 1. I think my answer is going to be, what's 4 times 3 is? 12 divided by 2 is what? Is 6. I think the combos is going to be 6. But let's go through and prove it. But it's not always going to be half, and you'll see some in just a second. But I needed to use these numbers because otherwise we would have gotten 60 up here, and it's too much. So 3 and 5 are working together. Is that the same thing as 5 and 3? Yeah, so we're not going to use it. Now they're just walking. The order does not matter. So 3 and 7, can I cross out 7 and 3? Because now I don't care what order they're walking in. 3 and 9, or I can say 3 and 9 are on the team. 9 and 3, they're already there. I'm going to use the walking better. Okay. So we're done with those. 5 and 7. Do we have a 7 and 5? Yeah, we can cross that out. Go to this one. 5 and 9. Do we already have a 9 and 5 walking? So we can cross that one out. So we're done with that one. 7 and 9, is that the same thing as 9 and 7 walking? Yes. And let's see how many do we have left. 1, 2, 3, 4, 5, 6. And is that what we got? Yeah. So this is our combination. So now I'm going to flip this over, and now we're going to do the little bit harder ones. Okay. But it's going to be easy if you have the technique. So this time, on the number 9, now we're going to do it the little faster way. How many digits are we going to be picking? What does it say? You're going to pick 3. First, we're going to do the permutation as if the order mattered. Like first, president. I should have put president. President, vice president, and who's the next one? Secretary. We'll put that. Okay. The order matters. I'm not going to draw it this time. Just know that we need 1, 2, 3 lines. So the first time, who could be president? The 3, the 5, the 7, or the 9. And just put it the first time. 3, 5, 7, 9. And I'm going to expect that you're all writing this. How many people is that? 4. But now, let's suppose 3 gets chosen. How many are left? 3. Then, let's suppose 5 gets chosen to be vice president. How many people are left? 2. Here's my permutation. And it's interesting that on permutations, you have more, the number's going to be higher because it has to be an exact order. So you can have AB and BA, where if it's a combination, you can't. That's why it's less. So on this one, 4 times 3 is what? 12. 12 times 2 is 24. So if it's a permutation, it is going to be 24. In fact, we didn't put down the answer on the other one. The combination was 10, and the combination for this one was 6. But you're going to see this one doesn't come out to half. So to get the combination, watch carefully, you put the permutation 4 times 3 times 2. But how many numbers was I choosing? 3. So I'm going to put, watch carefully because this is a little different. 1, 2, 3. And I start here with a 3. 3 times 2 times 1. So we know I could reduce, but I want you to see the numbers. So this top number is 24. What's the bottom number? 6. Guess how many combinations?
4.
It's going to be 4. That is it. So this is number 9. So we did the permutation, which if they had to be in the exact order, it'd be 24. But if it's a combo, they're just walking together, nothing can repeat, it would be 4. 3 times 2 times 1. Did I do that right? Equals 6. Yeah, that's it. Okay. So let's do this one. This time I'm going to choose 4 people. I'm going to choose either A, B, C, D, or E, and we want the permutation first. So I'm going to put 4 lines. 1, 2, 3, 4. And how many people could be chosen? This is first place, second place, third place, fourth place. How many people have a possibility the first time of getting first place? 5. Okay. Let's suppose A is chosen. How many people are left to get second place? 4. Let's suppose B is chosen. How many people are left? 3. Permutations is the easiest. How many people are left if C is chosen? 2. So let's multiply this together. This is 20. This is 6. 20 times 6 is 120 different possibilities. Wow. You don't want to make a chart with that. No. That would take us a week. That would take a whole page. But now we're going to do the combo. So the combinations of 4 people together is going to be a lot less because you can't have A, B, C, D and a D, C, B, A because it's exactly the same people in a group. So we're going to now do group combos. And how you do that is, again, you put your permutation over how many choices were we making? 4. So you start with 1, 2, 3, 4. You start with the 4. And you put times 2, times 3, times 2, times 1. Now I could cross reduce, but again, I'm just going to go ahead and go 120 over, what is 6 times 4? Is that 24? And I think that goes 5 times, because 5 times 4 is 20. It's going to be 5. What?
Can I say something?
What?
You can just cancel out the 4.
I know, but I didn't want to do it just yet because I wanted to use my permutation number, but I know it's 5. But now we'll go back and cancel because then we can cancel out 4 and 4, 3 and 3, 2 and 2, and what's the number? It's going to be 5. Okay. So we're going to look down at some of your word problems and what I thought I was going to give you today. I'm probably not going to give you. Hold on a second. All right, so let's see what they're saying. Okay. On the number 13, how many different ways can they be arranged? This is an order. Do we need the permutation or combination? Combination, you don't count the combos. The order doesn't matter. Permutation, the order matters. The order matters. So, how many different ways can they be arranged? Does the order matter?
No.
Well, it does. If they're saying how many different ways, can I have novels first? Yeah. Or if I have novels and then the art book, I can also have the art book and then the novels, because they're saying the order does matter. So this is going to be the easy one. It's a permutation. So it's going to be, I'm going to do it right here. How many different books are there? There's the novel, the art book, the history book, and the math book. Who knows what I'm going to put? And there's 4 different books. 1, 2, 3, 4. So 4 times what? Times 3 times what? Times 2 times 1. And so let's go ahead and look. That's 12 times 2 is what? Is 24. And that's the answer. Because the order matters. Okay. And then, because it says it matters. It says how many different ways can they be arranged. It doesn't say how many different combinations of books. Like, it doesn't say, no, it doesn't say that. It just, how many different ways can they be arranged? The arrangement is the different order. Again, I can put the art book first, then the novel. I can put the novel first, and then the art book. So I have to count all of them. So it's 24 on this one. This is the same thing. How many different seating orders? The order matters on this one. And permutation matters with the order. How can I figure this? The permutation order, like post office. Order matters with the permutation. And CD, with combos, it does not matter. But this is a little bit harder one where you have to divide. So this one is, the order matters. They want to sit together in the same row. So we're going to have 1, 2, 3 people. So how many people have a choice for the first chair? How many people are there? 3. If Mike takes the first chair, how many people are left? You need to be writing this down, sir. Times 2. And if Mike and Jim already took their positions, how many positions are left? 1. Multiply it together. There's going to be 6 different ways that they could be seated. Then, if 5 people want to be seated, how many ways can 4 of them be seated on a bench that seats 4? That one. Yeah. How many different ways can they be seated? It's kind of the same thing in what kind of order. So this time there's only how many seats available? 4. So I only can put 4 lines. 1, 2, 3, 4. But how many people are going to fight over the first seat? What? How many people are? 5. And if person A gets it, how many are left? 4. If person B gets the next one, how many are left? 3. And the next one is 2. Multiply those together and see what you get. It's what? 120. So there's 120 different ways. Okay. Okay. I think we're going to stop on 16. Okay. This is how many committees. If I have a committee of Leanna, I need 3. Leanna, Caitlin, and Ann. Is it the same committee as Ann, Leanna, and Caitlin? Yes. This one, the order does not matter. It does not matter. So they're going to form a committee of 3. So the combo is where, in fact, CD, the order does not matter, you divide. The CD combos, you divide. So first you do, by the way, how many people are there altogether? 5. So that's a little trick. There's 5 people. But we've only got 3 positions. 3 people are going to be selected. So I'm going to put on my top 1, 2, 3. We have a choice of how many people the first time? 5. And if 1 is chosen, how many will be left? 4. And then if B is chosen, how many are left? 3. No, we can't pick anybody else. Then on the bottom, when you're dividing, how many people were going to be on the committee? 3. So you go opposite now. You start with 3, then you go 2, and then 1. And now, so on the top it's going to be 20 times 3 is what? 60 over 3 times 2 is 6. And this dividing, where we canceled it all out, it does it for you. So we're left with how many? 10 different ways a committee can be formed. Okay. And we're going to stop right there. Then we're going to go to this one. Okay, listen carefully. This one is going to be so easy. In how many different ways can you arrange? This is an order. In how many ways can you arrange 6? It's an order, 3 things at a time. So I'm going to help you with maybe, not those 2 though. Let's go down to here. This is a hard one. You know.
Are these all like combinations or?
Well, you have to read it. We might start this and then finish it tomorrow. Hold on, I have to look at my lesson plan. What was I going to do tomorrow? I don't know. Yes, I do have it. Tomorrow was going to be permutations and combinations from Dolciani. Oh yeah, and E54 is on here. So we'll look at a couple of these because we don't have much time, so I don't want to give homework. All right. We'll look at this one, the number 11. Well, you know what I could do? I'm going to change a little bit. We're not going to do this today. We'll save it for tomorrow because then all we have to do tomorrow is this side, which, trust me, it's going to be easy. You'll find out it's going to be easy. And then we're going to do this kind, which is super easy, which is possible outcomes. This one is the easiest. This is the easiest. I've got 2 choices of drinks. I've got 3 choices of hamburgers. I've got 4 choices of lettuce. You just multiply 2 times 4 times 2, whatever. This is just going to be multiplication. So let's go back and we'll wrap it up here. Okay. What did she say? Okay. Let's go back to this one. We're going to finish this one up. So they've got 4 plants and they're putting it in 3 pots. Sir, listen. They've got 4 plants and they're putting it in only 3 pots. Does it matter if I have a carnation, a sunflower, and a rose? Or a rose, a sunflower, and a carnation? Does the order matter? No. So if the order does not matter, it is the divide one. So on the top, how many pots do I have? We've got 3. So we've got on the top 1, 2, 3. But how many plants is she going to plant? So you start off with the permutation 4 times 3 times 2 divided by how many different pots did she have? 3. On the bottom you go backwards. You go 3 and then what? 2 and then 1. And then this one, let's see if we can just cross off. Cross off, cross off, cross off, cross off. How many different ways can she plant them? 4. Okay.
Is there any like keywords on like combination?
No, sometimes you just have to look. One of the words is arrange. In which way can they be arranged? It has to be, your baseball team has to be arranged in a certain way. Your pitcher, your first place, whatever. So that's a keyword. How many ways can they be seated? That's a certain order. You know, is George going to go first? Is Sam going to go second? And so on. But this one, if you're talking about plants, there's no order to that. I mean, I don't know how else to say. So let's look at this one. All right. In fact, this one, how many ways can they choose the problems? There are 6 problems on a math final exam. Students must choose 3 problems to solve. Do you think the order matters on this one? No. So this is one though, if the order doesn't matter, I have to divide. So there's 6 problems. They only get to choose 3. So I need to draw 1, 2, 3 lines. So divided by, in fact, we can do the bottom. How many are we going to choose? So on the bottom, we're going to start with 3 times what? 2 times 1. So we've got our bottom. The top, you do your permutation. How many problems could I have picked from? 6 times what? Times 5 times what?
4.
Times 4. Can I reduce anything? No, let's just work this one out. This is easy. 5 times 4 is 10, is 20. Times 6 is at 120?
Yes.
120 divided by 6. What is that?
21.
20. So there are 20 different ways I could have chosen it. That is it, people. No homework.
Yay.
Okay. You're welcome. You can head on out. Could you turn on the light, Mateo? Thank you.
Are we eating today again?
Yes. Tomorrow we go to the FLC, or whatever it's called. Is it making a little bit more sense?
Yes.
Okay, good. And I need to get ready to go.
Oh, how were the questions I redid? Were they?
I haven't had time to look at it. I've got my 8th graders. Here's the reason. 8th graders are going to be gone all next week and the week after, and then grades are due. So I have to make sure the 8th grade stuff is done first.
All right.
Okay. Okay, come on
They took
in.
everything off of our locker.
Oh no, what a sad day. Did you understand the fractions?
Yeah, that was easy.
Okay, good. Woohoo! It's much better than adding and subtracting, huh?
Yeah.
Oh my gosh.
There's less ways that you can do it, so it's less confusing.
Yeah, I agree with you.
Wait, go here?
Yes.
Okay. So, I need to go to the restroom, but I don't want to go downstairs.
The boogeyman might get you if you go by yourself. Boogeyman!
Sorry.
We're ready to play some video game.
Maybe. And oops. Oh my god, you're so dumb, Alegra. What did I do? What do you mean? He dropped it, not me. I ran to the other side. No.
Alright, can I just said, oh no, I won't.
Literally did.
Distract yourself recording.
Is there a what?
Recording.
I guess I have to edit it.